Hello everyone, today we're going to be talking about head loss and piping systems. So first off, what is head loss? Head loss is essentially the energy loss due to frictional losses and viscosity. This is really important in fluid mechanics to calculate pressure difference in piping systems and also pump sizing and selection, such as when calculating the MPSHA. There are two different types of head loss. The first type is HL major, which is mainly due to friction loss. The second type is HL minor, which is due to valves, fittings, and bends. Altogether, the total head loss is equal to HL major plus HL minor. First, we'll talk about major head loss. Major head loss is calculated by using the formula on the screen, which is a friction factor times the length of the pipe over the diameter and then multiplied by the velocity squared over 2 times the gravitational constant. Now you might be wondering what F, the frictional factor, is. Well, the frictional factor is a relationship between the Reynolds number and the relative roughness, which can be calculated using the Moody chart. Once again, the friction factor for your piping system can be calculated using the Moody chart shown in the picture by using the Reynolds number, which is measured on the x-axis, and the relative roughness, which is measured on the far y-axis. You'll be able to calculate the friction factor. Minor head loss, on the other hand, is calculated using a different formula. HL minor is equal to the loss coefficient times velocity squared over 2 times the gravitational constant. The loss coefficient is determined on an individual basis, meaning you would need to calculate this for each problem you do. In the middle of the screen, I've attached a graph showing the loss coefficients for various elbows, bends, T's, and valves. This graph is very useful when working out problems in fluid mechanics. Using the information we've learned thus far, we can now start an example problem where we find the total head loss of a piping system. As you can see in the image, we're given a piping system which has 4 threaded 90-degree elbows, a wide open globe valve, and a nozzle with a loss coefficient of 2 based on the pipe velocity. The image also gives us the flow rate, which is 12 gallons per minute, and a diameter of 0.75 inches. Now, before we start calculating the total head loss, we first need to find the velocity. Velocity can be found using the formula Q over A. And before we start calculating, we would need to change the diameter to feet and the flow rate to feet per second. Doing those conversions, we find a velocity of 8.7 feet per second. Now that we have the velocity, we can start calculating HL major, which is shown using the formula on the screen. We can find the friction factor using the Moody chart previously shown, and by plugging in all of our givens, we're able to find a HL major of 24.26. Now that we have HL major done, we can now start calculating HL minor, which is calculated using the loss coefficient, the velocity squared, and 2 times the gravitational constant. The loss coefficient is given by using one of the tables on the previous slides and finding the loss coefficient for all 4 threaded 90-degree elbows, the wide open globe valve, and the given 2 for the nozzle. Adding this together and multiplying it by V squared over 2G, we get HL minor, which is 21.16. With HL major and HL minor, we can find the total head loss very simply by just adding them both together. 24.26 plus 21.16 gives us 45.42 feet. I hope you were able to learn something from this video, and this can help you in your endeavors in mechanical engineering and beyond. Thank you so much for watching.